Polyhedron. Polyhedra.
You know what?
That's plural.
It says
polyhedron. I was looking up here.
It says
Okay, most important thing, a polyhedron is a space figure that just means 3D, whose surfaces are polygons. Polygons are what we just spent that entire chapter doing, finding an area of. So like they're triangles, rectangles, hexagons, pentagons, entagons. Basically, it has to have 3 or more sides. And you have a polyhedron with you when you multiply them all together, or add them all together. Each polygon is a face of the polyhedron, so each different shape is a face. I like to think of it as just like a flat surface. An edge is where 2 or more faces meet, and a vertex is where 3 or more edges intersect. Those all sound like super hard words, but it's not that bad. If I look at my faces of this shape, I have my top, bottom, front, back, left, right. Those are my faces, okay? Those are my sides, if you want to think of the sides. Edges are where our faces meet, aka the lines. Okay, these are all edges. You got me? Okay? And then vertices are your points, where they all intersect, where your edges intersect. So point, 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 point. Those are my vertices. Okay? Think we got those words down?
No.
You don't think so? Well, let's try. How many faces do I have in the shape over here?
6.
6. I got top, bottom, left, right, front, back. I got 6 faces. Vertices. How many points do I have?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. And edges. How many do you think I got?
12.
12?
Yep.
Everybody agree? Yeah, I got 12 ones.
Yeah.
I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You feel better about our vocab? No? Okay, we'll do it again. Faces! I got 5, you guys agree?
Yeah.
Yep. How many vertices do I have? 5. And edges. 8.
Yeah.
8, yeah.
8. One more time. How many faces do I have in my little wedge?
5.
5?
Yep.
How many vertices?
6.
And edges. 9?
Yeah.
Okay. We have a little formula that's called Euler's formula that tells us the relationship between faces, vertices, and edges. Okay? You combine your faces plus your vertices. Now you're going to give me the rest of it. What's faces plus vertices here? 10. What's faces plus vertices here?
11.
How does it compare to our edges? What do you think?
2.
Yeah. So if I take my edges plus 2, I get the faces plus the vertices. Let's
say
do
it
it.
again. What did you just say?
Faces plus vertices, so when I add my faces plus vertices,
Yeah.
it equals my edges plus 2. So like, these are 2 away, and these are 2 away.
Okay, so
Yeah.
say you get the 11 by using that formula. How do you split that to make sure you have the
So you can only have one thing missing, just like normal formulas. So like, let's say you knew faces plus vertices was 10. You didn't want to count the edges or didn't know whatever. Then you just solve this quotient. Like you can't know just edges. You have to figure out both faces and vertices.
That
because you can't solve for two variables. Does that make sense? Alright, on the top of that next page, I want you to put that same equation. Faces plus vertices equals edges plus 2. So we're going to figure out if that's always true by counting faces. I got a hexagon on top and
8.
bottom. So I have 8 faces. How many vertices do I have? 12. And let's use our formula to figure out how many edges that means I should have. So if I take f plus v, so that's 8 plus 12. Should be my edges plus 2. 8 plus 12 is 20.
So 22.
So how many edges should I have? 18, so you're going to subtract 2. Count your edges and make sure we get 18. Yeah? We get 18? To figure out how many edges you have, you're gonna take the sides of your shape. So like my top I said was what shape? And how many sides does hexagon have? And how many hexagons do I have?
2.
So I have 2 hexagons that are 6 sides each. That'd be 12 sides. What's the shape in between my hexagons? Rectangles. How many rectangles do I have?
6.
And how many sides do rectangles have?
4.
When I add those 2 up, I get. But you'll notice that this side right here is a part of this rectangle and this
So
rectangle.
divided by 2.
So you got half. Which is where edges come from. Oh, just don't do that. Okay, we're gonna do it in this next one. Okay, so using Euler's formula to find our missing values, notice there's just one missing faces. I know edges and vertices, thank goodness, because I'm not gonna count all that. So my formula, f plus v equals e plus 2. What am I plugging in where? 20 into
V.
V, still looking for faces. What am I plugging in for E? 30. So my right hand side I get nothing? No? 32. So how many faces do I have?
Plus U.
Questions there? Okay, this next one we're going to use the thing I was just talking about that Euclid goes a long way to solve for vertices. So it says I have 7 faces, 2 pentagons, and 5 rectangles. I need to find the number of vertices. Notice I don't have how many edges there are. So in my f plus v equals e plus 2, right off the bat, I only know one thing. What's that one thing? Faces. How many faces do I have? 7. I'm looking for vertices so I can fill in the v. To figure out edges, like I said, we're going to need that little thing that we're doing up there. Okay? So it says I have 2 pentagons. How many sides is a pentagon?
5.
So I got 2 times 5 here, which is 10. And then I have 5 rectangles. How many sides is a rectangle? 5 times 4. So I get what there? 20.
30.
Total them up, we get 30. and then we know some of them share, so
Divided by 2.
divide by 2. And how many edges should I have? Questions on how we got that 15?
So you added 10 and 20 together to get the 30 and then divided by 2.
Yep. Okay, so this is my edges. So 15 plus 2, which gives me 17. So how many vertices do I have?
10.
Okay. Questions there? Okay. This last part is about cross sections, and like I told you, this is the hardest part that I have a problem with, is visualizing if I cut it, what it would look like. Okay, some of you will be really good at this because you're visual people. I am not one of those people. So if you struggle, I'm with you. Okay, a cross section is when we take a solid and just cut it. I think you do that in science sometimes, though. There's like cross sections of like fronds or something. No, nothing. So if I cut this parallel to my bases, you'll always have the same shape as your base. Okay. Notice this little dash thing is a triangle, just like my base is a triangle. Okay? The hard part for me is when we cut not parallel to a base. Okay? So notice this one says draw a cross section formed by a plane from the front, so this guy, and the right face. So the shape you don't have in your notes is this right here. So it's cutting through, doesn't matter where it cuts, it'll be the same shape. Could be cutting way back here, or it could be cutting closer like this one is. Either way, can anyone visualize what shape we would have? It's a rectangle. Because where this cuts are these red solid lines. So like I said, for me that's really hard to visualize. But luckily we talk about parallel stuff in here now. So like I said, if you just cut it further back, it's just gonna have a bigger rectangle. Different dimensions. What? I don't know. Okay. So we have a horizontal plane that intersects the left and right faces of the cube. So it comes in like this. That's kind of bad, but. So what shape would I have? A square? You guys agree? Yeah. Okay, how about if I cut this horizontally, parallel to the top and bottom? So we got something like that. What shape do I have there? Hexagon, same as our top and bottom shape. And same shape, but this time we have a vertical plane parallel to the front and back. So parallel to my front and back. I'll erase this one. Oh, lovely. Well, why don't you draw it? Let me know what you think. What'd you get?
Wait, no, I do it wrong.
So parallel to my front and back. What?
I don't get how you're
It makes
drawing the
no
line.
sense.
Yeah, this is just.
This shape is
Okay.
line.
So this is my front, right? And this is my back. So if I cut it, notice how it goes out. Okay? So if I cut it parallel to my front and back, I'm gonna end up with the same shape as the front and back. Except for since it goes a little bit wider, it's not gonna be like you might think this is a square. I don't know if it's a square. But since it gets a little wider as we go back or in between the bases, you're gonna have a rectangle. Questions? I think the more practice you get with them, the better you will become with them. That is all we have for today.